equals to 1 over x using first principle method. Here, y equals to ax plus b, where a and b are constant, still using first principle. So let's start with the first one. Solution. Y is equals to 1 over x. That's what we are given. The first step is to change this to become y plus change in y equals to 1 over x also will change, which is x plus change in x. That's it. Now, the next step, there's nothing we want to do here. The next step is to subtract y from this. So which is y plus change in y minus y. It's not difficult. Equals to 1 over x plus change in x minus our y is 1 over x. So we have 1 over x. This has become change in y because y cancel y equals to, now here we take their LCM. The LCM of this will give us x into x plus change in x. Right? Now, x plus delta x in this will give us x times 1, that is x. X in this, we have x plus change in x times 1. Remember this is minus, so minus is going to multiply. So that's x plus change in x. Now, if we use this minus to expand, we are having s minus x plus change in x all over x into x plus change in x. Because this in this will give us this. Alright, so this is minus because minus times minus is minus, minus times plus rather is minus, minus times plus also is minus. So here s cancel minus x. Still with, we are still in change in y. Now we now have change in y equals to, we are left with delta x minus delta x here. So we have minus change in x over x into x plus change in x. The next step now is for us to divide this by delta x, change in x. So we have change in y over change in x equals to this now minus change in x over x into x plus change in x. Now we are dividing by change in x. We can also say multiply both sides by 1 over change in x. It's still the same thing here. So here we have it as times 1 over change in x. So if this multiply this, we are having minus change in x over x change in x into x plus change in x. That's what we have, because x times this will give us this, and we have the same thing here. So change in x cancel change in x. We have change in y over change in x equals to minus 1 over s into s plus change in x. Then we take the limit. Limit as change in s tends to 0 of, and the same thing, limit as change in s also tends to 0. So this automatically gives us dy dx equals to, here we have minus 1 over, this is x into, here is x, x plus delta x, and delta x is 0. So that's x plus 0 x. So here we have x, and finally delta and change dy dx is equals to minus 1 over x squared. So if y is equals to 1 over x, then dy dx is equals to minus 1 over x. Now, the next thing for this number 2, they said we should use this. So I'm going to do that here. We have y equals to ax plus b. Take note that a and b are constant. This is now y plus change in y. Since a and b are constant, x is just the only variable we are looking at here, because a and b, they are not variable, they are constant according to what we are given here. So this is now a into x plus change in x plus b. They are constant values. So that is why we are only replacing x with x plus change in x. This is equals to, when we multiply here, we have ax plus a change in x plus b. The next step, which is the second step rather, y plus change in y minus y equals to ax plus a change in x plus b minus y is ax plus b. So minus into bracket ax plus b. So that is, here we are having change in y. We are having change in y equals to, this is ax plus a change in s minus b, minus times all of that will give us minus ax minus b. So minus as cancel as, and this is plus b, rather this is b, minus b cancel plus b. So plus b cancel minus b. We are left with change in y equals to a change in x. That's also what we are left with. Okay, this has cancelled. All right. Now the next step is to divide both sides by change in x. So here we have change in x. This is change in x. Why? It's because the only variable we are considering here is x. So we have change in y over change in x equals to a, because change in x cross change in x. Then we take the limit. Limit as change in x tends to 0 is equals to limit as change in x also tends to 0. But here we do not have change in x. So the answer is equals to a. Because limit of a constant is still that same constant. So here we have change, that is the y, the x is equals to this. And that is the value of this. So what is the implication of this? This is implication that the derivative of a constant value is 0. We observe here that this is constant. The derivative of this constant value is 0. Now, just say for instance, we have something like this. We have y equals to, let's say, c. We have to find the derivative of this. This is constant. If this is constant, using this same first principle method, we say y plus change in y equals to, there's nothing we want to put down here because there's no variable here. So it still equals to c. Still equals to c. And this is now y plus change in y minus y is equals to c minus y is c equals to c minus c. Here, y cancel this. We have change in y equals to 0. C minus c is 0. If we divide both sides by change in x, this is change in x. This is change in y over change in x equals to 0. 0 over anything. So this is limit as change in x tends to 0, which is the y dx is also equals to 0. So the derivative of a constant value is equals to 0.
Subscribe to my channel.